Hi there, welcome to today's video. In today's video, we are going to continue to implement the paper direct speech-to-speech translation with discrete units. In the past two videos, we have implemented some of it, so let's just recap. In the first video, we went through the steps for data preparation and formatting the data, and then in the second video, we trained the model with the data that was prepared. So after we train the model, what we will have is a checkpoint, or we can say a trained model that will be stored in the directory that we specify here under the save directory argument. So let me show you what it looks like in my case. So in my case, I specified this as the location where I wanted to store the checkpoints. So here you just see one checkpoint, which is called the best checkpoint, but what you will see if you follow the steps that I have followed, you will see several checkpoints here. So in my case, I was saving the checkpoint after every 10 epochs. So I had several checkpoints here, but I only care about the best checkpoint because this is what I will be using during inference. So once we have the trained model, now we can proceed to the next step, which is testing the model, or what we also call inference. So we're going to take the trained model and we are going to test how good the model performs on a test set. So let's get started. The inference, according to the steps here, it is in two steps. So in the first step, we will take the model that was trained in the previous video and we will use it to predict the discrete units for the test set. So remember, this model is going to take the speech in the source language, and its task is to predict the discrete units in the target language. So the first step during inference is to create those discrete units or predict those discrete units using the model that was trained. And then after we predict the discrete units, then as a second step, which is here, we will convert those discrete units to a waveform which we can listen and then evaluate whether the waveform contains the target speech or not. So let's go through the first step first. So we'll just use a fair-seek generate command line tool and we will specify the arguments. So as you can see, the first one is data root. So this is simply the location to the directory that contains our data. Remember, we specified the data root in one of the previous steps before, so it's the same one. So let me show you what it looks like in my case. So inside my data root folder, I have dev tsv, test tsv, and train tsv. So these are the three TSV files that actually contain the data in the format that this model understands. So let's look at test TSV as an example. So here you can see, here on the left side is the source speech in the source language, in my case Punjabi, and here target audio is the target discrete units for the target language, which is English. So this is the data that we will give to the model for testing. So that's the data root, and then we specify the config file, config multitask file. These were both created before and we used these in the training as well. And then next task, speech to speech, target is code, so we'll keep everything the same. Next is the path where the checkpoint is stored. So we'll just specify the path that contains the checkpoint, best checkpoint That is the model that we are going to be using for inference. And then finally, here we need to specify the set of the data that we want to do the inference on. So in my case, I have 3 sets. I have the train, I have the dev, and I have the test set. When I did the training, I specified the train set and the dev set. In this case, I'm just going to specify here test, because that's the name of my test set. Finally, we will just keep the max token as is, and we'll keep that as is. And then here we are going to specify the path to the directory where we want to store the results after the model predicts using the trained model. So when we run this command, what we are going to get is this results path wherever we specify. At this location, we will see a text file, and the name of the text file is going to be generate dash, and then whatever we specify here, in my case test, so it will be generate dash test.txt. so this is the file that will be generated as a result of running this command. So let's look at an example. Let me just show you the command first. So again, these are just my notes. This is the same command that we saw in the GitHub. I just specified the arguments that I need to specify, such as the location of the data and location where I want to store the file, and the location of the folder where my trained model is stored. So this is just for my own convenience. I like to just put the command here so that I don't have to type in the arguments every time I run it. So after we run this command, it's going to generate the text file. So let's look at the text file. So let me point out a few things that you will notice in this text file. So for each sample, there will be 4 things predicted. So these are the 4 things. You will see T dash and then bunch of numbers, H bunch of numbers, D bunch of numbers, P bunch of numbers. So you will see 4 things for each of the samples in the test set. And so this is for a sample number 350, and then this is next sample number 180, but you will see 4 things. So T, H, D, and P. So, and you can verify that for all the samples. So let's take another example. Let's see. Yeah, so 240, right? Sample number 240, you will see T, and then H, and then P, and then you should have D. I probably skipped it, so D, 240. Okay, so for each sample, there are 4 things that we get in this text file. So let's understand what these 4 things are. The first one here is the ground truth. So these are the actual discrete units for that particular sample, and we generated these discrete units, I believe, in the first video when we created the when we were formatting the data. So that's when we created these discrete units, when we created when we used the Hubert model. So these were created a while ago in the steps that we did. So this is the ground truth. D is the discrete units that are predicted by the model. By the way, this you can ignore. So the discrete units are these. So again, T is the ground truth. These are the actual discrete units in the target language, and D is what the model predicts, discrete units that are predicted by the model. And for now, we can just ignore H and P. I honestly don't know what H and P actually are. I can make a guess, but I don't want to tell you something that I'm not sure about. So let's just skip that for now and move to the next step. Actually, before we move to the next step, I really want to highlight something. So as you notice here, see here the first sample is called T-350, and then the second sample is T-180. So what are these samples? So these samples actually are, so if we go back to the TSV file, so remember, we are giving the TSV file as an input, which is located in our data root folder here. So as you can see, in this TSV file, I don't have the same name for the samples, right? So here the name is simply 350, 180, but here I actually have the names that are 1671, so I have a sample ID and then some numbers. So how do we relate these? How do we know which sample do this correspond to? So it's actually pretty simple. So inside the TSV, whatever is the sequence of the sample, so for example the first sample here 1671_1, which has this for which this is, by the way, source language, and this is the corresponding target discrete units for this particular sample. So this first sample here corresponds to sample 0 in the generate text file, and second sample corresponds to T1, third sample corresponds to T2, and so forth and so on. So here the numbering starts from 0 and goes all the way to however many number of samples we have. So 0th sample corresponds to the first sample, so on and so forth. So that's how, if you want to check that, we can do that real quick. So let's try to verify that, right? So let me go to the actual TSV file that I actually used. Give me just a couple moments to log in. I'm sorry, I actually didn't mean to go here. I meant to go inside the TSV file. So sorry about that. Okay, so let's just open the test.tsv file and inspect what we have there. As we can see, the first sample here, 1987_1, the target discrete units are there. So maybe I'll just take a sample from here and try to find this in the generate text file. So if I go here and then I just try to find that sequence, and you will notice that I found the ground truth here, and it corresponds to T0, which is the first sample. And similarly, if I, let's say, search for this third sample here, I should be able to see this as T_2. So let's just verify that. There we go, so T_2. So now we know what this generate text file has and how to interpret what samples this corresponds to in the test.tsv file. Okay, so we're good with this generate dash text test.txt file. Now let's move on to the next step. So what we have done so far is we have predicted the target discrete units. And again, those are in this generate file with the tag d dash whatever. Now we want to convert those target discrete units to a waveform so that we can actually listen to the waveform and actually verify that the content of the waveform is the expected target speech. So for that, what we will do is, let me open up my generate file again. So here, from this file, we just really care about everything that is inside the d dash, because these are the predicted target discrete units, and we want to verify. We want to convert these to raw waveform and verify. So what the next command here that they specify, this one, grep and all that. So this command, what it does is it is going to extract everything from this generate dash test.txt file that has the d dash prefix. So it's going to extract this, it's going to extract this, it's going to extract this, so you get an idea. So it's going to extract everything that is predicted by the model, which is actually everything that has a prefix d dash. So that's one thing. And it is also going to sort these d dash sample count in the ascending order. So what we mean by that is, so if we try to find for d0, so this is the first sample. So when it extracts everything with the prefix d dash, it's also going to sort. So you will see this being the first thing in the list when we run this command. So when we run this command, we will actually create a new file. It's going to be called generate dash test.unit. So let me show you a sample of what that file looks like. So it's located in the same location because that's what I specified. And then let's open this up. So as you can see, this only contains numbers because we ran that command to specifically extract everything that was with a d dash prefix, and we also sorted it. So first sequence of numbers here, it corresponds to the first sample, and these are the predicted target discrete units. So let's verify that. So if I try to search for this in the generate test text file, I should be able to see that for sample 0. So let's try to find it, and there we go. So d dash, and we found this. Let's try to test one more. So maybe we test the third sample. So let's copy this, and we should be able to find a match in the text file where we have d dash 2, because 0, 1, 2. So let's try to verify that. There we go, d dash 2. So as you can see, it seems like h is the same as d, but let's not worry about that because all we care about is this d for now. So this generate dash test.unit contains the target discrete units. So now the next step is, for each one, we are going to convert this sequence of target discrete units into raw waveform. Before I go there, let me actually make sure that I covered everything that I wanted to up to this point. So we covered that, and then we ran this command, And then, yep, so we covered everything up to here. So next is we want to convert the target discrete units to a waveform. So for that, we will just use this Python script, generate waveform from code, and we should be able to convert all those target discrete units into a waveform. So in order to run this, let's see what we need. So we need to specify the path wherever this file is located, generate-test.unit file is located, and then we need to give it the location of the vocoder. So how does it convert the discrete units from how does it convert discrete units to the raw waveform is that we use a pre-trained vocoder. So that vocoder can be downloaded from the page here. Yeah, I believe it's this checkpoint and the model of the vocoder. So once I have already downloaded those to my machine, so then we just need to specify the vocoder checkpoint wherever that is located and the config file, and then finally we need to specify the path wherever we want to store the predicted or the converted waveforms. So let's quickly look at my commands here real quick. So as you can see, actually I need to point out, when we run this command, the one I talked about, generate waveform from code, you actually need to be inside the fairseek folder, because that's where you will find these examples, speech to speech, and then this file. Okay, so I don't have to go into the detail because we just discussed how to run this command. So after you run this command, what you will see is the results, which are the predicted waveform, and they will be in the folder that you specify. In my case, I specified all the results to be stored in this folder, so you can see all the waveforms are here, and the 0 underscore predict corresponds to the first sample here, and then similarly 1 corresponds to the next sample, 2 corresponds to the third sample, so forth and so on. And again, if we want to relate this back to the TSV file, which is inside the data root folder, so again, so this is the source audio, and then target audio. This is what we are trying to predict. This is the ground truth, and what we just did was we predicted the target discrete units, and now we are converting the target discrete units to waveform. So if you compare what you have here and what is in the folder is this. So let's go back to the inference here. Okay, so if I compare them side by side, this first sample in the TSV file is the source audio, and this first sample is the translation of this source audio in the target language. So if sample ID 1671_1 waveform is the Punjabi speech, then 0_predict is the corresponding English speech. Same thing, next sample, this is the Punjabi speech, and this is the translation of that in English speech. Third one, it's Punjabi speech, and this is the English translation of that particular sample. So this is how we have the mapping here. So with that, what we have done is we now at this point we have the target waveforms. Now how do we evaluate that the target waveforms are correct? So for that, we can actually listen to each one of those waveforms and verify manually, or we can use some other techniques. So that's where the next step evaluation is important. So in the next video, I'm going to cover how do we evaluate those predicted audios that we just saw. So in this video, what we have covered is just the inference. We took the model that was trained here for speech to unit translation model that was trained, and then we used that trained model to do the inference on the test set. So what we have at the end of the inference is the waveforms in the target language. In the next video, we will focus on evaluation. So for now, I'll stop here, and I hope this video was helpful. If you like this video and find the content useful, please consider subscribing, and I will see you in the next video. Thank you. Bye.